Okay, in this video I want to go over the two types of weld joints that make up the ones we use in the test. They're going to be fillet joint, and next one will be a groove joint. So I have some models I made here. I want to go through all the parts of the weld and talk about them in detail so that you get a good mental picture of what you're looking at before you start welding. So this is a typical fillet joint. This can be like a leg like this, it could be a T. So the parts here are, okay, when you're looking at the joint, alright, this part right here is the leg, called the leg of the weld. Here's the other leg right here. And in this, okay, I take this little piece over here to show you, the weld itself is going to sit right there, okay? It will go across from the leg to leg, okay, right here. That'll form your weld area. Now, a good rule of thumb is, well, how long should my leg be? Okay, whenever you're setting up a weld, okay, the thickness of your material, okay, is the length of your leg. So this is 3/4 of an inch thick. My leg length is 3/4. I'm 3/4 over here. Okay, same is true of a T. If this were a T, for instance, it would be 3/4 here, here, 3/4 this way, 3/4 this way. So that's a good rule of thumb, okay? You don't want your leg length, okay, to be any less than the material thickness that you're working with, all right? So then going over here, okay, that line over here becomes your toe, okay? The edge of your weld is your toe. Here's the other toe up here. And an imaginary line running through the center of your weld, that is your weld axis. So whatever position you're welding in, okay, we've got 4 of them. Okay, so for instance, this would be flat right here. Alright, flat is this way. You would be welding straight down into it like that. That would be your weld axis this way. Okay, horizontal like that, your weld axis is here. In the vertical position, like this is your weld axis this way. Now in the overhead position, which I can put just like that, it's hard to see, but underneath your weld axis will be running that way. Okay, those would be the 4 positions. So your weld axis is the direction you're moving. So let's take a look at this also here. Okay, so the dotted line on here, this represents what's called the heat affected zone. So outside of your weld zone, which is white area, okay, the heat affected zone is an area where the chemical and mechanical properties of the metal have been changed due to the heat of welding. That area is something you want to minimize as much as possible, and excessive heat can cause the metal here to change to the point where now it's lost significant strength and mechanical properties, and it can fail. So it's something, the heat affected zone is something you want to watch out for and really take a look at. It should be as small as possible, and it should be even. If your heat affected zone is all wavy and all over the place, it's a clear indication that your weld is kind of stopping, starting. Your application of heat is extremely irregular. You want to look at that. Okay, and one important thing to keep in mind is the white area is your weld zone. Okay, you may not have any arc strikes or any kind of weld activity outside of that zone. That is qualified as a failure, and it's a big no-no. So if you're welding, okay, let's say this is a welding rod right here. If I'm starting this weld, okay, I'm going to strike over here, bring it back, then I'm going to complete my weld through along the weld axis inside my weld zone. Okay, I'm not going to strike over here and then go in here, ever. You don't do that, okay? That's not permitted. You must keep your weld inside this weld zone. How big is the weld zone? Again, that is equal to the material thickness of the material that you're welding. So you can actually chalk this all out or Sharpie it out so you know exactly where you're going. So this is a typical fillet weld. Now let's go through things that are really not too clear in the book in static pictures. Okay, the first one is, okay, your angle. Okay, now this If this is a 90 degree joint, this would be my weld angle, okay? It's half of whatever the joint is. In this case, it's going to be 45 degrees. So you would want to keep your rod at 45 degrees throughout the duration of the weld. It's not going to do this, it's not going to do this. You're going to be right in there. This is going to push the penetration into the corner, okay? If you're up like that, you're pushing into here. If you're over here, your penetration is going there. It's not going into the joint. So to get into the joint, focus it into the joint. Very important. Okay, so this is your work angle. The next one is travel angle, and for those of you who've done machining, this is called a compound angle. So keeping that 45 degrees, let me try and angle it here so you can see it. So keeping it at 45 degrees, just like that, okay, looking straight down, you're going to actually move now about 10 to 15 degrees in the direction that you are welding, along your weld axis. So as you're moving, you're going to be moving like this, okay? The tip of your rod is lagging behind where your hand is, about 10 or 15 degrees, okay? A good rule of thumb is, if it has slag, you drag. Okay, we do not push weld, which is this kind of an operation. You're going to drag your rod behind you. You're firing back into the puddle. Okay, what that does is that keeps your cloud of shielding gas formed by the flux coating on the rod around your pool as it cools. Okay, and lets it cool very nicely and gives a nice slag shield over your weld, keeping your weld in good shape. If you're push welding, your shielding gas is going where you aren't, in front of you. You're not there yet, and you're not getting enough on your weld that's cooling behind you. So again, you're going to be at half of whatever the angle of your joint is, and then 15 degrees or 10 degrees in the direction you are going. Okay, so if this were a flat weld like this, I'd be straight up and down. Okay, straight up and down, and inclined a little bit, and I'll travel this way like that. If this were a horizontal weld like this, you know, this would be position 2F. I would be inclined a little bit, 45 degrees, and go right through my zone just like that. Vertical. Now vertical is a little bit different, okay, because vertical weld, if you drag like this, you remember now we have the influence of gravity, so that's going to change things a little bit. In a vertical weld, you want your rod to be as flat as possible, okay? That is, if it turns sideways, you're going to be like that, okay? You're going to be 90 degrees or perpendicular to the weld axis and out halfway, whatever the angle is, which is 45 degrees, and then you go up your weld just like that. Okay. Now in overhead, you do the same thing. Split it, angled about 10 or 15, and away you go. Now another one is, how big of a bead do I do? Now looking at this material here, okay, 3/4 of an inch thick, pretty thick stuff. So how many beads does it take me? How many beads am I going to have to lay down to fill this joint? So I need to fill this entire triangle right here, okay? That's a right triangle with 3/4 leg, 3/4 leg. I need to fill this with metal. So how many passes is it going to take me? Now there's a quick way to estimate this. Alright, so your rod, if we look at the rod right here, okay, a quick estimation is this, alright? Your beads may not be any wider than 3 diameters of whatever your rod is, okay? This is your limit. You may not go beyond that, okay? This is it. Now this is including slag, okay? Keep that in mind. So this is including the slag on the outside of the rod. So when you do chip the slag off the weld, this will actually be slightly smaller, leaving exactly the right size bead. So it may not be wider than 3 diameters of your rod, nor may it be thicker, okay, than 1/4 of an inch. So that's about the same thickness as the rod is, about 1/4 of an inch thick. So this gives you your size. Now if you think about that, in here, that gives you how many passes it would take to fill this particular space. Okay, you can kind of do a rough estimate. I would say for the entire volume, this would be like 1, okay, 2, 3, 4. I mean, we've done this in the classroom, so for something this size, this would probably be about 6 passes, okay? So it's a rough way of estimating. This can be really good for figuring out, like, well, how many passes will this joint take me? How many rods do I need to pack or have at my disposal for working? But also when we do the tests, the 3-rod rule is really good, so you're not making massively wide welds, nor welds that are too narrow, okay? You want welds that are just right. So this is a very good model right here, okay? And that's what we want to do.